So we want to, when it comes to integration by parts, there are a few of them that you really need to know uh, quickly as soon as you see them. Some of the one is, of course, has to do with natural log of x, but that's another story. So some that are related to integration by parts in tabular method, which is today's discussion is tabular method. The ones that are related to tabular methods are usually a polynomial, let's say times a function of x e to the power nx dx, or another polynomial, cosine of nx dx, and polynomial sine of nx dx. These are good candidates for tabular method. So how does tabular method work? Let's give an example of that. So let's say you want to take an integral example, and you want to take the integral of, let's say, x to the power 4 times e to the power 3x dx. So what you see is that you basically want to use the integration by parts by setting this as u and setting this as dv, to reduce the order, the degree of the polynomial. And so when you do integration by parts, you end up with a term plus an integral, and the integral has the polynomial in it of degree 3. And then so you have to do it one more time and one more time until the polynomial vanishes. So if you write this in a nice, clean way in a table, it will look like this. And sorry about that. So it will look like this. At this point, I want to write x to the 4th in here. And over there, I want to write e to the power 3x. And divide them by a line. And then what I want to do is, with a polynomial, I want to take the derivative until the polynomial vanishes. So 3/4 x to the 3rd, and then 12 x to the 2nd, then 24x, then 24. And with the other function, I want to take the antiderivative. So antiderivative of that is e to the power 3x divided by 3, then e to the power 3x divided by 9, and then e to the power 3x divided by 27, then e to the power 3x divided by 27 times 3, 81. Oh, this hasn't vanished yet. Let's put it, the next derivative would have been 0. And so I still need one more. So e to the power 3x divided by 81 times 3, which is 240. Okay, so that done, the next step from there is that you start from very top row and you put a positive, then negative, alternate positive, negative, positive. This would be negative, but then multiply 0 eventually, so it doesn't matter. Then diagonally go and multiply one term from there with a term below it on the other column, and times that sign that you wrote, basically. And so what you end up with is right here is x to the 4th, e to the power 3x divided by 3. Here is negative 4x to the 3rd, e to the power 3x divided by 9. Here is positive 12x squared, e to the power 3x divided by 27. and it's negative 24x e to the power 3x divided by 81, and plus 24 e to the power 3x divided by 243. And so the solution to this integral is all of these terms added together. It's just all of those added together. It makes your life a lot easier because you don't have to do that many integration by part.